using Windows machines all the time, it's kind of incredible that since 93, I think, up until 2010, it's incredible to know that these flaws have been present in Windows. Because if you finally understand the vulnerability, it's like all the authentication attempts that you were doing were not secure at all. And that has a very big impact in everything that you do. And but the slide says that it's a 14-year-old vulnerability because actually before coming here, we were able to track down a version of Windows NT 3.1 and 3.51, and then we checked that those versions were also vulnerable. So actually, the vulnerability has been present in Windows for 17 years. Also, if you understand the vulnerability, I mean, if you were to check for this kind of, if you want to assess the security of a child response protocol, these would be the things that you will go and look for. Because the thing that cannot happen is that the challenge or the nonce should not repeat. So it's also very interesting to know that actually this was happening. And I'm not trying to bash anyone with this because no one is perfect and no one can find all the vulnerabilities. Just from, I don't know, from a historical point of view, it's just amazing that we just found these issues. And also, like I said, the passive replay attacks, I think, are very interesting, which also, I think, makes the vulnerability more severe, I think, because just by doing nothing, you can gain access. Also, well, if you have Windows NT servers, I know they are like very, very old, but I know companies that still use them for some reason. In those cases, there's no patch because it's not supported anymore because it's very old. So if for some reason you are still using Windows NT, you have to actually verify what function these machines are actually doing inside your network. If you're doing some critical function, don't use them anymore because you can't rely anymore in the authentication method that everyone is using to gain access to the machine. So you can't use them anymore. Also, if you have appliances, for example, that have Windows versions that are not updated or old Windows versions that will not have the patch that Microsoft already released, they are also vulnerable. All these versions, or all these appliances and all versions of Windows will be vulnerable to this vulnerability. What is, I don't want to say special, but what is different in this case is that this is not like a buffer overflow or something where you are executing code in the stack or in the heap or something like that. Because for those vulnerabilities, even if you don't have a specific patch for that vulnerability, you can have some kind of generic anti-exploitation tool, something like that, installed in the machine to prevent generically all buffer overflows from executing code in the heap or in the stack. Or if you have an IDS that is looking for certain signatures of an exploit, you can also check for that, even if the machine is not patched. But in this case, since what is failing is the authentication itself, how do you check that? Because, like I said, an attack would look like someone just trying to authenticate against the server. So I don't know of any IDS systems that actually are looking for this kind of bugs, because they will actually need to keep a lot of state of the packets that flow through a network to understand that somebody is actually doing this attack. So this is also something that even nowadays, when you have a patch, you need to, I think, have into account to know that everything is secure. Also about this vulnerability being an elevation of privilege, we don't agree with that. First, because we don't know what is an unauthenticated elevation of privilege vulnerability. Because, I mean, elevation of privilege is when you have some privilege and then you gain more privilege. And if you have no privilege and then you gain privilege, that's not an elevation of privilege. Because that's like saying that when you find a remotely exploitable buffer overflow, that's an unauthenticated elevation of privilege. I don't think that's the case, because that's how it works. You don't have any access, you exploit the buffer overflow, and you gain access. Yes, you were unauthenticated before, but that is not an elevation of privilege. And also, the advisory says that this can be used to upload and download files and access SMB resources, and that is true, but what the advisory does not say is that it also can be used to execute code. And if you take a look at the advisories for the SMB credential reflection vulnerability, in their website, Microsoft itself says this is a remote code execution vulnerability when they're talking about SMB relay or SMB credential reflection. And this vulnerability to execute code needs to have the same context and has the user that you are attacking needs to have the same privileges that the user that you're attacking when you're doing SMB relay has to have. So if that vulnerability is considered a remote code execution vulnerability, this should be considered a remote code execution vulnerability as well. So that's why we don't agree. And we're going to show you that we can execute code. So before going into the conclusions, we are going to try to do some demos to see. Let's pray. I hope that nothing fails. All right. So the first thing that we're going to demo is the passive replay attack. We're not going to demo because you need time just to sit down and listen to the traffic. So we don't have that time. So the attack that we are going to demo is first what we call the active collection of duplicate challenges. So basically, we have a virtual machine with SP3. And we're going to try to, that is vulnerable to this vulnerability, obviously. And we're going to do the attack against that machine. And we have to wait for it to boot. So the first thing that we're going to do is, like I said when I tried to explain this attack, is we're going to get a number of Nonces from the server to have just a list of Nonces generated by the server. And we're going to grab around 8,000. And this is just because the number was calculated using heuristics. But you can actually improve that. There's a lot of things that you can do to actually improve all the attacks that we're going to show you, but you need to spend more time. And after the patch was released, we just stopped researching about this. Correct. All right, so this is basically, say DAPS 0?
No, lo voy a guardar, pero voy a mostrar los duplicados.
No, let's show the duplicates first. Okay, we're going to make a change. First, we're going to show you how much time you have to wait until the server generates a duplicate. So we're going to run a Java program that we did that basically connects to the server, gets nonces or challenges from the server while trying to perform NTLM authentication, and we're going to see how much time you have to wait for the server to generate the duplicate. And this machine is very slow. No, but I think that the VMware server was booting. Well, that took like 2 seconds. And then you see another duplicate, another. Every time you hear a beep, it's a duplicate. The server is generating a duplicate. So as you can see, the plots that we did were true. There are a lot of duplicates, and within a very short period of time. So now what we're going to show you is the active collection, the active collection of duplicate challenges. So we're going to run this other program that basically is gathering Nonces from the server, just to have a list of Nonces. After we have that, we are going to force the client to connect to us and give us the responses that we need for those Nonces to build the dictionary.
We can also reboot the machine, for example.
Pues.
Run?
No, tiene que firmar.
Okay.
Tiene que firmar las cosas con Internet Explorer. Now we're going to simulate, I don't know, let's say that we send an email or somehow we made the victim connect to our website. So basically, we're going to simulate the victim connecting to a custom SMB server that we wrote, that basically for every connection attempt, authentication attempt that it gets using NTLM, will send back the responses or Nonces that we got in the previous step and get from the client the corresponding responses that we need to create the dictionary. So basically, we have like a common web page with 2 iframes where you can see that you can fool the user like with a game of lemmings or whatever, and in the background, the code that we're sending is actually connecting to our custom SMB server. That's it. Now go to the customs. Yes, all right. So basically, it took us like 2 seconds. Now we have the dictionary. That was it. It was not like a lengthy process. Edit the file that has all the, I think it's /temp/challenges. No, /temp/save2.log. So this is a dictionary. The first line is the nonce that we send to the client, and we made the client give us the response, and all the other information is the NTLM version 2 response in this case. So basically what we're going to do now is we're going to reboot the virtual machine altogether to prove that you can use that against different machines, because by rebooting the machine, we're basically erasing the internal state of the PRNG. It's like having the dictionary and coming back, I don't know, 1 year later to the same machine and trying to do the attack with that information that we grabbed 1 year ago. And we're going to show you that after rebooting, the server is going to generate the same nonces that we obtained some time ago. This is also one thing that makes the attack, in our opinion, a good attack, because you can spend, I don't know, 2 seconds to create a dictionary, and then you can come back whenever you want and just use the dictionary to gain access to the machine over and over and over again. So the exploit that we're going to show is basically, like I said, it's going to use DCE RPC over SMB. It will create a service on the remote machine, upload the file, start that file, that is an executable file, as a service, and that will basically connect back to us using the code that we use to grab a shell from the Windows machine. Now we have to wait. How much time do we have? 20 minutes? All right.
Okay.
So now this is like attacking a different machine or coming back to the same machine 2 days after we did the first stage of the attack, that is creating a dictionary. So we are going to run the attack. No, but it was not correct. Did you log in? That's it. So basically what that part of the exploit did is start connecting over and over again against the server until the server returned one of the nonces that we had in our dictionary. At that point, the exploit sent back the response we got from the client. We gain access. Since this was a user with administrator privileges, we were able to start a new service that was actually our code, and that code connected back to us and gave us a shell. And that's it. So exploiting this vulnerability takes you 20 seconds, I don't know. And then, for example, we can leave and try again. That's it, it worked. That means that the server generated another duplicate challenge that we have in our dictionary. And you can do this like forever. You can reboot the machine again, even go to some other machine and try the same thing, and that machine will generate a duplicate challenge also.
Well, let's go with the prediction.
You want to ask something?
In all fairness, it looks like you have the firewall turned off.
And of course, you have to have SMB open, because this is exploiting a flaw in SMB. So
you remove a couple layers of defense.
no, but that's like saying, okay, I put the machine in the bottom of the river, it's safe. Now, what we are exploiting is a flaw that is present in a service that you need to use. If you are in a network, in an internal network, and you are sharing files among the company, it's very likely they're going to have the SMB service running. Of course, if you shut down everything and you don't provide that service, if you cannot reach service, you cannot exploit any kind of vulnerability in that service. But that's something that happens all the time. It's not something that we are removing layers. You have to, where all vulnerabilities exploit a problem in a service that you are using. If you are not using the service, so you cannot exploit anything. Does that answer your question? You're not happy with the answer? But let's say that you have a flaw in SMB that is a remote buffer overflow. Just because you have the firewall app, that means that no one can exploit that? No, because if you actually want to use SMB, that everybody uses that because it's like the most common way to share files between Windows machines, also to access the registry, to do administration, to everything. You will need that service, and you can't just